Morning. Am I audible to you guys?
Good morning, ma'am.
Morning.
Good
So,
morning, ma'am.
latest.
Good morning.
Sorry, I'm late today. So, forgot my whiteboard today. So, I'm just going from manage. Can you see the screen?
Yes, ma'am.
Okay. So, in last class, yesterday class, we basically learned about language. I guess language part is clear to everyone. Basically, for this subject, we are mainly concerned about three things: language, automata, and grammar. So language means it's like any language, like how we human interact with each other. Computers also have their own language, and for that we have certain symbols. And with the help of symbols, we can create alphabets. With the help of alphabets, we can create strings. Then with the help of strings, or you can also think it like a sentence, we can create a language. Okay, so language can be finite or infinite. So what is an automata? Automata is basically an abstract mathematical model which will tell you whether a language is finite or infinite. Or as you can see, in case of finite, what you can do, means automata can do, is that suppose for this example, L1 is a set of string with length 2. So here there are four possibilities, right? So that's why it is finite. So if question comes like whether a particular string is the part of a language or not. Okay? For example, in English, we generate a sentence with the help of grammar, right? So next we will discuss about the grammar. So I'll come to that part. So question comes like a string is given, then it asks whether that part of the string is a language or not. Okay. So one thing you can do is that you can store all the possible strings in your automata. Then whenever you get a string, you will just match with the stored strings. Okay. So if you find any match, then you will just say that okay, that string is acceptable by the language, or it is included in the language. Okay. But in case of infinite, it is difficult. Means if there are infinite possibilities, how can you store such amount of strings in a somewhere else? It's difficult to store. Means even if you can store, it will be quite difficult to find a match. There are infinite number of combinations with two strings. Here I have given like set of all strings starting with A and ending with A. There can be so many other types of languages, and there will be variety of possibilities. Now, if I suddenly ask you whether this string is a part of language or not, it will be very difficult. Okay. Share the studies. Yeah, I was giving the example of last class, this yesterday class. So for finite case, you can store all the possible strings somewhere, then in the memory, then you, whenever you find a string, you will just match with the stored string. Okay. But in case of infinite strings or language, if I give you a match, it will be very difficult to find a matching string in the stored memory. Okay, so these both things are done by your automata. Okay, now as you know, for English also we follow certain rules, right? We have grammar like subject, verb, objective. Then there are so many rules to create any sentence in English. For example, like um, you can say like any sentence. Today is flat class. Okay, so this sentence you can just write like anyways, but it will be in English words, but not the English language. Okay, share the screen. So today we will see. Okay, grammar. So for any language, grammar is very important to form any sentence. I guess screen is visible now. Screen is visible, right? Okay. Simple example. Okay. Someone answered. I'm a boy. Okay. I'm a boy is a simple English language. Okay. You can consider it as an English sentence only because everything is in a proper setting. Like I, after subject, there will be verb, then there will be object, and so many things. But if I write something like boy, a, I am, it won't be a proper sentence, right? You cannot just put your words here and here. Okay, it will simply some English words. It's applicable to any language. We always follow certain rules to create a perfect sentence, then only we consider it as a language. So similarly, for computers also or for normal language also, there are certain grammars. So grammar is just set of rules through which the strings can be generated. Okay, it's more like a syntax. With the help of this grammar or syntax, we can create sentence. Okay, we can describe a language in a proper form. Okay. So in flat, we have a specific definition for grammar. So grammar we can represent with the help of four quadrants. You can say four tuples. So grammar by definition we can represent it as four tuples. You can represent it as grammar G equal to N T P N S. Always remember this definition. This is a formal definition of a grammar. NTPS. I'll come to the part what is N, what P. So grammar you can define with the help of four tuples or four things. N, P, P, and S. So what is N here? N is a variable. Okay, and it is also known as non-terminals. In some places, in some definition, you will see it as V N. It's V N N. That means non-terminals. Okay, N is a variable. Okay, that means here you can replace anything. I'll come to the example part also. Here in variables means what? The value can be anything. You can replace the values in that variable. Okay. Next comes your T. What is T? T is a terminal symbol. So you can also simply say terminals. Okay. In some places you will see it as sigma sign. Okay. In some definitions. So in some definitions variables are V, N, and in some places terminal means sigma. Okay, just remember there will be a variable, there will be a terminal. So what is a terminal? Terminal means there will be an end to your language or string, right? So with the help of terminal, you are going to terminate your string, okay, or the whole language. Next, what is P? P is the production group. So what are the production rules? These are basically some rules. Following these production rules only, you can generate the strings. Okay, so to generate the strings, you must follow the production rule. Otherwise, you cannot write a grammar. Okay? Now, most of the time, production rules are already given. Okay? So based on the given production rules only, you can create a string or the language. Okay? Next, S. S is the start symbol. S is the start symbol. Starting means we will always start or initiate our grammar from a particular symbol. Remember in algorithms, we always start from the start word, then we end with the end word. So you can just match it up with that. There will be a start symbol. From the start symbol only, we can create different strings. Okay. So just remember, grammar is a set of rules through which we can generate different strings for a language. Okay. So grammar, or it's more like a syntax, is helpful in describing language with large number of sentences. Okay. Grammar is first defined by a scientist, Noam Chomsky. So this is the formal definition about grammar. It's a collection of or a set of quadruples or four tuples, non-terminals, terminals, production rules, and start symbol. Always remember that. Okay. Now let's see an example. So, as you know, grammar is a non-terminal. So, what is non-terminal? Most of the times, non-terminals are capital letters. Okay. For example, I am writing a grammar SAP. So these are your non-terminals. Non-terminals, remember, it will always start with the capital letters. Next, there will be some terminal symbols. Let's say A and B. So these are your terminal symbols. Okay. Then we will have a starting symbol. Normally, S is the starting symbol. In all places, we get a starting symbol. So this is a starting symbol. Then we will have production rules. Okay. Now I'll show you how production rules looks like. It's A, B, A to A, B. Okay. So this is a complete grammar. Grammar always comes in this non-terminal symbols, terminal symbols, there will be a starting symbol and the production rules. And production rules will be always given to you guys. So here S, A, B, you know these are non-terminals. That means they are also variables. Correct? And small ab are the terminal. Means the moment you will reach A and B, that means that's the end of the string. Now let's see how you can create a string from the production rules. For example, here production rule is given as equal to A, B. One second rule is given A to A and next B to B. Okay, so this set of rules are given to you. So since it means what? From S, you can generate A and B. Okay. Now from A, you can generate small a, and from capital B, you can generate small b. Okay, so just start what can be the possible strings. So as you know, S equal to A and B. From A is replaceable by small a, right? From A, I can replace A, and from B, I can replace B. Okay, this is the simplest one. So AB is a string, or this is one of the possible string accepted by a language. But here you see there are only two possibilities. From S you can go to A and B, and from you can just replace A and B. So that's how we can generate a tree. From starting symbol, you see what are the non-terminals. From non-terminals, you see if there is any production rule available. So you will know from non-terminals, you can create, means you can shift to the terminal symbols. So the moment you will reach terminal, that means just end of the string. That's the only string you are generating on. Okay. Another example I can give you for like small production rules. Okay, so from these production rules, I can generate only this one. Now let's see what can be the other production rules. For example, I am saying from S, I can create an empty string. It is also possible. from the starting symbol itself, you can create an empty string or lambda string. Or I can also create a string A, F, and B. Okay, it is also possible. So these two production rules sometimes also given as S, A, S, B / epsilon. That means from S, you can create both. You can either select this ASB or you can select the empty string. Okay. So since S is the starting symbol, what can be the possibilities? Possible strings can be there. From S, you can simply generate epsilon. Okay, so epsilon is one of the string. Right. Now let's take S equal to A, S, P. Okay. Now from ASP, S you can replace directly by lambda. So you can just terminate it. So AB. So AB is another possible string here. Okay. Now you say from here A, this S you can again replace with the same ASP. Correct? So if you want to replace it same ASP, A, S, D. I'm just directly doing this one is already done. So one string is empty string, one string is A and B. Then again you write ASB. Okay. So from here you can replace same S by ASB. You will be there. Correct? So you are replacing this S with another ASB. Okay. So now from here, if you want to replace directly S, then it will be AA and BB. Correct? Next, I'm just replacing S with the empty string. So another string is AABB. Okay. Next, you can try other things. A, S, B. You can keep replacing S with ASB. Okay. Then you can again replace this S with another ASB. Correct? B and B, and so on. And finally, you can create AA and B. So now you see, if you keep replacing this, there will be so many other possibilities to create a string. Yes, this way it will go on and on. Yes, it can go to up to infinite number. There will be so many possibilities. Now, but you have to see the pattern. Okay. Now, if you notice, all the strings you have generated are Sila, A, B. A, B, B means you can also write A square, B square. A square, B square. Next, you have 3A. You can write A cube, B cube. Okay. So if you keep going on, it will be go A4, B4, and so on. Up to maybe AN, PN. Correct? If you keep replacing it, somewhere it will go to up to n, right? So most of the strings, if you see, are in this form. AB, then double A, double B, then triple A, triple B. You can just write A square, B square, Q, A, O, and on. So you can say this language is of the form A, N, B, N, where N greater than equal to 0. Correct? So this is your language. AN, BN. That means equal number of A and equal number of B. Now, if you replace n with anything, suppose you start with 0, that means what? A power 0, B power 0 is empty string included. Now you replace n with 1, A power 1, B power 1, that means AB. Then you replace n with 2, that means A power 2, B power 2, again included. So this whole thing you can generalize in this form, right? So this is your language. And any string, if I give you any string, you just need to check whether it is following these conditions or not. Equal number of A and equal number of B. But again, see, A will be always followed by B. Okay, A will always come before B, or you can say A will be followed by B. It should be only in this format. So any string which will follow this format is part of this language. This is the generalized an or en, where n greater than equal to 0. Okay, is this part clear? How we can create strings and we can generalize the language? Yes, it is a bit confusing, but if you keep doing it, it will be easy. It's actually interesting when you keep doing it. So all you have to do is you check the production rules. All your strings and languages are based on the given production rules. So I have given this production rule, and with the help of this production rule, you are generating a language which will have equal number of A's and equal number of B's. And A will be followed by B. Okay. We can see another example. Let's see the top. Suppose just take the same one. Okay. S equal to ASB. Okay, I'm giving another production rule. BSA. Then another giving B. Okay, so now I can create these things. You can also separate it or keep it same. It's fine. It's totally fine. It means people can give you in any format. It can be like slash, or they can just give you like separately ASB, S equal to B, SA, and S equal to epsilon. Same thing. Okay. Now let's see what are the strings we can generate from here. One is already clear. From S, you can directly generate an empty string. Right? So from S, let's take the first one. AS. So from here again, we can just simply generate AB. Correct? One string. Next, I want to take BSA. From here, I can create only BA. A is the empty string, so it's B and A. Okay, so like previous one, we can also keep going on like ASP. Now from here, from this S, I can also replace with BSA and P. It is also possible. You have production rule and you can use any one. It's up to you. There is no boundary in that. For this one, you have to use only like ASB1, or you can only use BSA1, nothing like that. You can use anything. Okay, so for this S, I'm replacing with BSA. Now this might look like AB and AB. Okay, S is the empty string. This is another possible string. Okay, so similarly, you can also write strings like BSA you can replace with A, S, B, A. So string will be B, A, B. It is another possible string. Again, like previous one, A, S, B. You can keep replacing A, S, B, and so on. That means you will get A, B, B, and on. So similarly for BSA also you can create B, B, S, A, A. Similarly, B, B, A, A. So what you can notice here is that this is also a language. So you can see strings can be epsilon. String might be like AB. It can also commit like a BA. It can also commit like AABB. You can also generate BBAA. You can also create BABA. You can create ABAB and so many. Yes, all are possible. Means there is no specification where A should come and where B should come. Okay, correct? There is no such thing. Now, in this case, what will be your language generalized? If we want to generalize it, we can say number of A is equal to number of B. Okay, but there is no sequencing. Like in the previous one, I wrote like A and B because A will be always followed by B. But in this case, nothing like that. One term is same. Number of A is equal to number of B. But there is no sequence. Sometimes A might come first, sometimes B might come first, sometimes AB, sometimes BA. There is no sequence to that. So in generalized term, you can just write number of A equal to number of B. Okay. And will be same greater than equal to 0. This is greater than. So see, the whole structure of your language and string depends on your production rules. So, in this language, will accept all the strings where number of A will be equal to the number of B, and they can be in any order. In some forms, you might also say like same thing. You can also see it somewhere like maybe W is given for that number of A is equal to number of B. It's same, just that number of A equal to number of, and it can be of any form. Okay. Grammar part here. At least sometimes it is like when you see it, it's very easy, but when you do it, a bit confusing. So just know what is a grammar. Grammar will be always set of non-terminals. From non-terminals, you can go to the terminals. And the moment you reach the terminal, it's just terminating the story. That's the end. So in a grammar, you will have non-terminal symbols. Non-terminals are always capital letters. Then there will be terminal symbols, always in small letters. Then there will be production rules. With the help of the production rule only, you can generate a string. Then you can finally generalize the language. And there will be starting symbol. Starting symbol is like from where you are going to start generating the string. Okay, just a little bit confused. Yeah, it is confusing. ये तो शुरुआत है, आगे आगे लिखना और भी confusing. But if you understand it, it's actually very interesting. So we can create different types of language from your grammar. So हाँ terms या initially थोड़ा वो होगा बाद में याद आ जाएगा. Just yeah, terminals, small letter alphabet, non-terminals means your variables, capital letter words. बाकी रहा production rules वो दिया ही रहेगा और starting symbol is always S. So sometimes what happens, questions are like for competitive exams, grammar is given, then they ask to tell the language like this one. A production rules means whole grammar will be given with the production rule. Then you have to decide what will be the language, what will be the possible language. Okay. Simple one, for example, grammar is given. So you can try it yourself. Huh? Yes. This is A, 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 A. Okay. So this is the grammar given. You need to find, sorry, language. You need to find a language from the given grammar. Okay. So you guys tried this one at home. Okay. Don't get confused. Just follow which one is the variable, which one is the terminal sequence. Okay. Here there are only two non-terminals, S and C. Only two terminals, A and B. Then production rules are given this. A capital C, then from C, again is A, or you can go to. Okay. So, do you want me give you the answer and you will check whether it is correct or not, or you want me to give the answer later? सर पहले बोल दूं मैच करके देखोगे या तुम लोग बोलोगे फिर मैं बोलूंगी ठीक है कि नहीं later. Okay. This one you try. Find the language. Okay. So this meeting is going to end. I will stop share. I guess everyone noted down. SC, AP, AS, ACA, PC again. You can go to ACA. Take attendance. I'll share the notes today, then you can just share. But problems I'll mostly do in class. Whatever problem we discuss in class, those are okay. Thank you all. सब लोग try करना ये वाला. Then I'll tell you the answer in next class. Yes, simple. Whenever you see terminal symbol or variable, keep replacing it, whatever production rules you have, and keep checking what can be the possible strings. And based on the string, you just need to generalize the language. Okay. Okay, I'm ending the meeting now. Thank you all.